Solving quadratic equations. Okay, it's quite a bit harder than solving linear equations. So this first example is a linear function. So how do you know that this line is describing a linear function? So pretend it goes on forever in both directions. You know it's linear because the graph is a straight line. That is the definition of a linear function. Okay, now can you describe the function? So the linear model is y equals mx plus b, and you need to identify these two features. You need to find the y-intercept and the slope. Okay, the b, the y-intercept, where this line intersects the y-axis is right there. So b is happening at a -3, and then m is the slope, and the slope, if you just connect some dots, the slope is the rise over the run, how far you're going up and over. So you're going up 2 over 1, and from dot to dot, up 2 over 1, it's both up is positive and right is positive. So the m is 2 over 1, or just 2. So the function is y equals 2x, I guess, minus 3, or plus a -3. So that should be a review from 9th grade math. Linear equations, linear functions, linear graphs, they're all pretty easy. So linear equation, these are two examples of linear equations. 2x minus 3 equals 3, so kind of the cops and robbers. If you're going to solve it algebraically, so they want to know 2 times something and then subtract 3 ends you up at 3. What is it? So cops and robbers, let's undo the subtraction first. Add 3, add 3. So you got 2x is equal to 6. Now undo the multiplication. Divide by 2, divide by 2, x is equal to 3. And then this one over here, 2x minus 3 equals a -5. Add 3, add 3. 2x is equal to a -2. Undo the multiplication. Divide by 2, divide by 2, x equals a -1. Okay, now let me show you how to do it geometrically. Let me show you how to do it visually. Okay, this line is the line y equals 2x minus 3. That's this right here, the 2x minus 3. So this line is the part 2x minus 3. So now, here's what they're doing. Y equals 2x minus 3. So I'm going to take this equation right here, and if I flip-flop the sides, it says 3 equals 2x minus 3. So the 3 is the y. What they're asking is, when is this equation gonna cross the y at 3? So when is the y going to be 3? So when does this line, this is a line right here, the 2x minus 3, when does this line cross the y at 3? So on your y-axis, this is your y-axis, the one going up and down. 3 is right here, this level, 3 high. So the answer to this equation happens right here at this dot. And to get to that dot, so if I have like a table full of dots, this dot is over 1, 2, 3. The x is 3 and the y is 3. Whoops, the y is 3. Okay, you already solved for the x. You already found that the x is equal to 3. The x is 3 when the answer is 3. The x is 3 when the answer, which is y, is 3. So look at this next one. Okay, they want to know, when does this line cross -5? So -5 on the y is clear down here. this line crosses negative 5 right there. So to get to this dot, I go over 1, down 5. So negative 1, down 5. And you already know, you solve it algebraically. X is equal to a negative 1. But if you're looking at it geometrically, it's easier. It's way easier. When does this line cross at a negative 5? It crosses negative 5 if you go over 1 to the left. Okay, so linear, that's a linear equation. That's a linear graph. Now let's look at quadratic. Okay, this is a quadratic. This is the definition of a quadratic function. And this is the parent function. So look at these dots. Let me highlight a few landmark dots. So this dot right here is 0, 0. This dot is over 1, up 1. This dot is over 2, up 4. And this dot is over 3, up 9. So here's what's happening. The next dot is going to be over 4, up 16. And then over 5, up 25. Over 6, up 36. So this pattern, all they're doing is squaring it. So your function is to get the y, all you do is take whatever the x is and you square it, you times it by itself. And then notice this graph, so it's not straight, it's curved. This is called a parabola. And parabolas are symmetrical. So this dot right here also shows up on the other side. It's reflexive. This dot right here also shows up right here. So in your table, a 2 will give you a 4 because 2 times 2 is 4. But this, a negative 2, will also give you a 4 because a negative 2 times a negative 2 is also a positive 4. A 3 will give you a 9. 3 times 3 is 9. But so is a negative 3. A negative 3 times a negative 3 is also 9. So this is it right here. That is your most basic quadratic. Take whatever the x is, square it, and that gives you the y. So look at these equations. This is the parent function of all the quadratics, so it's just y equals x squared. Now let's just do it geometrically. When is it going to equal 4? When is this graph going to spit out a 4? It's going to spit out a 4 2 times, once on this side and once on this side. So x can be 2 and y will be 4, or x can be a negative 2 and y will be 4. When is it going to spit out a 1? It crosses the 1 twice. And it crosses that. A negative 1 will give you a 1, and so will a positive 1. When is it going to cross 9? Crosses 9 clear up here. But what the big picture is, there's going to be 2 solutions because it's a parabola. You're going to cross it 2 times, once on the left side, once on the right side. So x can be 3 and a negative 3. Okay, now this one's kind of tricky. When is it going to cross 0? At 0, there's actually only one solution. And this point right here is called the vertex. So that's the point where it turns around and starts taking off the other way. So what you plug in to get a 0 is just a 0. And this question is the best question. When is this graph, this x squared, when is it going to cross at a negative 1? Negative 1 is down here. And the answer is, for now, it's never. Or you could even put no solution. Okay, so let's look at linear versus quadratic. Let's kind of compare and contrast. So pause it, see if you can answer these 6 questions, and then push play, see how your answers match up. Okay, a linear equation, what does it look like? It looks like this. 2x plus 3 equals 7. A quadratic equation looks like this. 2x squared plus 3 equals 7. So the difference is the exponent. If the exponent is 2, it's a quadratic. If the exponent is 1, it's linear. Okay, the graph of a linear equation, the graphs look like some line with slope. So they look like that, or they look like that. Parabolas are graphs of quadratics. They look kind of like a U. Or you could flip them upside down and they look like that. Okay, how many solutions will there be to a linear equation? There are only going to be one, because it's only going to cross one time. Parabolas, though, they have two, because you can cross 2 times. I guess if you cross at the vertex, 1 at the vertex, and you could have down here, if you cross below the vertex, there will be no solution. So no solution below the vertex. Or if the vertex is right here and you're crossing above it, then there's going to be no solution. So kind of no solution below or above the vertex. Okay, now this, I think this idea is introduced in 3rd grade. So the zero product property. If A times B is 0, then either the A is a 0 or a B is a 0. So if you're multiplying and your answer is 0, that means you must have multiplied by 0. So what do you know about x if x times 4 is 0? You know that x equals 0, because the only way to get 0 as an answer from a times problem is if you times by 0. So now this one's a little more complex. What do you know about x if x plus 4 times x minus 3 is 0? Okay, you could say this is the A and this is the B. So you're timesing them and your answer is 0. That means you must be timesing by a 0. So either A, which is x plus 4 equals 0, or the B, which is x minus 3 is the 0. So one of these two quantities has to be a 0. So this one, x would have to be a negative 4, or this one over here, x would have to be 3. So those two values would give you a 0 for an answer. Now this is a big deal. This is going to make our work way easy with quadratic equations. So here we go. We're going to use this idea, the zero product property, to solve these quadratic equations. So we got an easy one, a medium one, and a hard one. The easy one, here's what's nice. It equals 0. Now, if we could rewrite this so that it was a times problem, so that it was something times something, and our answer was 0, then that would be way easy. And you can manipulate this by factoring it. So this is the answer to a product. Let's factor it, and you've already done hundreds of these, so hopefully it's not too bad. How do they times and get x squared? Just x times x. How do they times and get 32? But you've got to add them to get a negative 12. So 32, we're going to go, you can do 1 and 32, 2 and 16, 4 and 8, and that's where we're going to go, 4 and 8. So they've got to multiply and give you a positive 32, but you add and get a negative, so that means they are both negatives, because a negative 4 times a negative 8 is a positive 32, and a negative 4 plus a negative 8 is a negative 12. So now here we've got it written as the product of two binomials. So this is my A and this is my B. So A times B is 0. So that means either A is 0, so X would be 4, or this one, X would be 8. And these are my two answers. And it's going to have two answers because it's a quadratic. So as soon as you see the exponent 2, that means to your brain there's going to be two solutions most of the time. Unless we're crossing at the vertex. Okay, medium. This is different than the easy. The easy was already equal to 0. And mine is equal to 6. So what I want to do is I want to make it look like the easy. I want to make it equal to 0, and I can force it to. So if I minus 6 and minus 6, here's what I've got. I've got n squared minus 10n plus 21 is equal to 0. Now it's equal to 0, so if I can rewrite it as a times problem, then it would be pretty easy. So rewriting this as a times problem is not too bad. You just factor it. So what's going to times and give you 21, but at the same time add or subtract and give you a negative 10. So I'm going to go n, and I'm going to go 3 and 7. And it's going to be minus minus. Because a negative 3 times negative 7 is a positive 21, but when you add them, it's a negative 10. So that means this, my n has got to be either a 3 or a negative 7. Or no, sorry, positive 7. Okay, the last one, the hard one. I'm going to make it look like the easy one. So I want it everything on one side and I want 0 on the other side. So I'm going to take this over here. So I'm going to add 15n, and there's nothing to add it to. There's no other n's. So I'm going to have this 5n squared, add 15 and add 56 is equal to a plus 4n squared. Okay, now I'm going to take this 4n squared over, so I'm going to minus 4n squared, and I'm going to minus it from this, because these are like terms. So 5n squares minus 4n squares, that's just 1n squared, add my 15n's, add 56, and now on the right hand side I've got nothing. I've got a 0. So now the question is, if it's equal to 0, can I rewrite it so that it's a times problem? Can I make it look like this? And it's pretty easy. So n and n, what timeses and gives you 56 but adds and gives you 15? And that is a plus 7 and a plus 8. So if this quantity times this quantity is equal to a 0, one of these two quantities must be 0 itself. So what do you plug in for n to create these zeros? You plug in a negative 7, or you plug in a negative 8. Okay, that is it. Good luck on your homework.